going on, STAR students? It's time for part 3. Get that A on that final exam.
That's right, guys. Hey, we're trying to get this A on this exam, man. So watch the videos over and over again. All right. Use them to your resources. Let's go ahead and get started. All right, guys. Hey, right here for Unit 9. Hey, it says for the function, graph the function. Part A, we're going to do that. I'm going to show you how to do that with your calculator. Part B, tell whether the graph opens up or down. Identify the vertex. State the transformations of the parent function. Absolute value of x. State the intercept. State the intervals of increase and decrease. And then write a piecewise function. Guys, piece of cake, man. Let's go ahead and do it. Graphing this, all right. First of all, graphing this, you can actually do it in your calculator. I'm going to show you how. Let me make this bigger so I can, of course, sketch it. This says the absolute value or the function of the absolute value of x plus 2. All right, let me show you how to do this in your calculator. If you go to your calculator, now, right here in your y equal, guys, y equal, we're going to graph this. And what I want you to do is press the button math, then press the right button here to go over the number. And ABS is for absolute value, guys. If I click that, all right, I can put the equation right there. Well, that's x. And then remember, outside we had, was it plus 2 or minus 2? That was definitely plus 2. So we have plus 2, like so, okay? Now I hit graph. And the calculator will actually sketch your absolute value equation for you, like this. All right? So we're going to go ahead and sketch that in. We went up 2, all right, as you can see. So I'm going to go here, 1, 2. Now let me see if I can draw this thing, man, with this beautiful handwriting of mine. Boom, and boom. All right, there's your graph. Oh, I didn't mean to do that third part. Boom, there we go. All right, there's our graph, okay? Now let's answer a couple of these questions. All right, it clearly opens up, all right? The vertex is right here, 0, 2. All right, 0, 2. The transformation, guys, it went up 2. The x-intercept, guys, this doesn't touch the x-axis anywhere, so there is none. The y-intercept, here it is sitting on the y-axis. The vertex is on the y-axis, so the vertex is also the y-intercept. The intervals of increase, all right, from left to right. This will be a decrease. This will be an increase. So this increases from x is 0 to positive infinity. All right, because as it goes to the right, guys, this thing never stops increasing. Now decreasing, all right, this decrease, all right, is from negative infinity. Remember negative infinity is way out here to the left. So we have negative infinity out here. So from negative infinity to 0 is where this thing decreases. All right, that's the decrease right there. Okay. So now we need to write a function. All right, write a function of the piecewise function. And again, guys, look, all you do is drop the absolute value. All right, we're just going to solve it. So you have x plus 2, right? And then you have and then you got to have a negative of that. So you have negative x plus 2. Those are our two functions. All right. X plus 2 and negative x plus 2. Okay. So now we just identify which way it's going. All right. Negative x plus 2, which is this way, left. All right. Negative x plus 2. And this way, right, is x plus 2. All right. So here we're going to say x is greater than 0. All right, we'll put the equal to under that one. And here we're going to say x is less than 0. All right, x is less than 0. We don't need the equal to on that one. So there's our equations right there, guys. All right. Let's go ahead and look at number 18. 18. All right, we have x minus 3 plus 1. Again, with your calculator. we're going to go y equals again, you press math, and we're going to do go over to the number, absolute value, option 1, and we're going to put in inside the bracket x minus 3. And then on the outside, we have plus 1. Okay. And then we hit graph. This thing should move right 3 and up 1, which it did. Right 3, up 1. That's shown. All right. So let's go back and sketch that. Made this a little bigger so I can get it on there, guys. All right. So the vertex is right here. 1, 2, 3, up 1. There's the vertex. So let's sketch this thing, guys. Here and here. Sorry, mine is kind of off, but that's it right there. All right. Now, this thing opens up, of course. All right. There's no negative out front, so it opens up. The vertex is right 3, up 1. All right, so 3, 1. The transformations, as I just said, was right 3, up 1. All right. Now, our x-intercept. Guys, notice this doesn't intercept the x-axis, so we have none. Our y-intercept, we have 1 present. All right, and this should be, well, mine's a little off. It should be right here, 0, 4. So I guess I need to fix my graph. Let me fix my graph. Because if you looked on the calculator, matter of fact, I'm just going to show you. See right here, 1, 2, 3, 4. It intercepts right there at 4, okay? So don't let my drawing distraught throw you off right there, man. It's terrible, okay? Now the intervals of increase and decrease. As I increase, all right, to the right, this value is 3, so this way is the increase. So from 3 to positive infinity, all right, and then from negative infinity to 3 is my decrease. All right, see that from negative infinity out here, this whole time this graph is going down, okay? Now the piecewise function, all right? If we take this function right here, remember, and how you do it is, if you go back to that unit, I have this as face value. I'm going to solve it. So I go x minus 3 plus 2. I mean, plus 1. Sorry, guys. I'm thinking about the answer. X minus 3 plus 1. And you just solve it. So right here you have x minus 3 plus 1. With negative 3 plus 1 is going to give us x minus 2. All right, so that's one equation. All right. For the next equation, I'm going to take the same equation right here, but I'm going to put a negative out front this time. Like that. All right. So now when I solve it, guys, you end up with negative x, distribute the negative, so negative x plus 3, my plus 1. All right. And negative x plus 3 plus 1, with 3 plus 1 is 4, so you have negative x plus 4. Okay? So now, how do you solve this thing? All right? And how you solve it is this, or how you figure out which equation goes in which direction. All right? Well, look at the y-intercept. See, this one has a y-intercept of 4. All right, that's 4. So which way is that going? See, the y-intercept right here was 4. It's really 4. That's to the left. See how this line's going to the left? So this would be negative x plus 4, which means the other side, this is x minus 2 right here. Because if I kept that line going, I would intercept right here at 2. All right, it would intercept, well, I can't trace it. There we go, at negative 2. So that's the y-intercept there. So this is to the right, where x is greater than 3. And this is to the left, where x is less than 3. And just give one of them the equal to sign. It doesn't matter. All right, it doesn't matter. So there is your piecewise functions for this one, okay? Now for this next part, we need to evaluate this following piecewise function. Now, for this piecewise function, guys, the function here is -6. All right, -6, where x is greater than 2. So here's 2. All right, at -6. So that means all the x is greater than 2. The answer will be -6. All right, now I just made a mistake, and the mistake I made was I put an open circle. I mean a closed circle, and the answer should be an open circle. And the reason it's an open circle is because see how this is not equal to? So it doesn't actually equal that, but it's going to go this way, okay? Now right here where the answer is 4, all right, the answer is 4, all the x's are less than 2. So here's 2 right here, all right, 4, and because it's equal to, we have a closed circle, but remember all the answers are less than 2. All right, so we go in the left direction, okay? Now, right here it says evaluate each piecewise function for x is -3 and x is 4. Well, for this first part, when we evaluate it, you got to look at the condition, okay? So where f is -3, all right, where x is -3. All right, it's -3. Ask yourself, is -3 less than 4 or is -3 greater or equal to 4? All right, and in this case, -3 is less than 4. So the answer or the equation I would use is right here. In this case, it's 10. So f of -3 is 10. For f of 4, all right, you got to ask yourself again, is 4 less than 4 or is 4 greater than or equal to 4? Well, it's definitely greater than or equal to 4. So the equation we would use is right here, or -1 in this case, okay? Now, over here, we're going to do the same thing. We have f of -3. Look and see which condition this x value fit into. Is x less than 0? Is x between 0 and 4? Is it greater than 0 but less than 4? Or is -3 greater than 4? Well, -3 is less than 0. So we're going to use this expression, guys, right here. So I'm going to evaluate it as 3 times -3. Plug in that x, all right, where x was, -1. So what you get is 3 times -3 is -9 minus 1, which is -10. All right, so we get -10 right here. Let me slide that over for you. All right. For the next one here, f of 4. All right. As you can see, 4 goes right here. 4 is greater than or equal to 4. It is, so it would go right here into this expression. So we get 1 minus 4. Oops. 1 minus 4, and 1 minus 4 is -3. All right, so these are my two answers. All right, this is f of 3, this is f of 4, okay? Now, let's go ahead and look at number 22. And this should be pretty familiar because we just took a test over similar things right here. Whoa, that's some glitching. All right. So now, a constant, guys, which polynomial would best fit the data if? All right, got to read the directions. All right, a constant first difference, guys. Remember, that is linear. All right, a constant with second difference is quadratic. A constant with third difference is cubic. A constant with fourth difference, is quartic. And a constant ratio, guys, is going to be exponential. Man, I totally misspelled that. Sorry about that. I was thinking about exponential for some reason. All right, exponential. Sorry about that. Now, let's go ahead and go down to number 23. 23. Man, I don't know what is going on here. All right, with 23, guys, it says describe the R-squared value when the regression model fits the data set perfectly. All right, guys, this is when R-squared equals 1. All right, when it's perfect. That means it's 1. What happens to the R-squared value when the regression model least fits the data? All right, when it least fits data, guys, R-squared is 0. Okay. Now for 25, man, that's disturbing. Let's see. Oh, went too far. Let's see if we can get back there. Now, we're going to use the constant difference or ratios to determine which parent function would best fit the given data set. Okay. All right, for this one, guys, again, all these you can use your calculator for them. All right, so we're going to talk about that. For this first one here, I don't see a constant rate difference. All right, we're like 10,000 plus 1,000 plus another 1,000, right? That's not a constant increase. All right. So what we're going to do is we're going to put it in the calculator like so. You're going to go to your calculator. You're going to press, well, first of all, let's get out of this screen. Hold on, bear with me. We're having some technical issues right here. All right. Let's see here. Only a second, quit right here. I want to go to the main screen. Now, I'm going to press Stat and then Edit. And I'm going to put those items into these lists like so. All right. So we have 3, 5, 7, 9, and 11 for list 1. And for list 2, we have 10,000, 11,000, 12,100, 13,310, 14,641. All right. So those are the elements we're going to put in our set. All right. So go ahead and enter those into your calculator if you have one with you. All right. And then let's continue. So once these items are in my calculator, I press Stat again. All right, we're going to go to calculate this time. And what you do, guys, literally is check it, man. Try it. All right, we're going to try linear first. Just try it. All right, and look at the R squared. R squared is 0.996. All right, let's see if we can get closer to 1. All right, stat edit again. All right, I'm going to try quartic. And you just try it. All right, it doesn't hurt to try. All right, quartic, R squared is 1. All right. Now, guys, hey, I also went ahead and did exponential for you. And the reason I did exponential is because I want to show you this is actually exponential. It's a common ratio. Here's the reason why. If I take all these numbers and multiply by 1.1, all right, I'll get the next value. All right. All right, this is exponential. All right, I know quartic showed a R squared value of 1, and that's fine. But this one, given, again, if I multiply this by 1.1, it's going to give me 11,000. If I multiply that by 1.1, it's going to give me 12,100. All right, or if you divided all these, you get 1.1, okay? For this one, man, let's see here. I'm going to do this one by hand just to show you. All right, if I did 1 minus 2, I'd get negative 1. If I did 2 minus 1, I'd get 1. If I did 5 minus 2, I'd get 3. And if I did 10 minus 5, I'd get 5. All right, now, if I did 1 minus negative 1, all right, listen to what I said. I said 1, remember how I did 1 minus 2 and got negative 1? Well, I do the next term minus the previous term. So if I do 1 minus a negative 1. 1 minus a negative 1. The negatives become a plus, which is 2. If I do 3 minus 1, I get 2. If I do 5 minus 3, I get 2. So now I have a constant difference right here. All right, the 2's, which means this is going to be quadratic. All right, it's quadratic with a common difference of 2. All right. Now, this next part, C, I'm going to do this again by hand, okay? If I go negative 22 minus 27, all right, listen, negative 22 minus a negative 27, that becomes a plus again, doesn't it? So that's really 5. If I go negative 17 minus a negative 22, that becomes negative 17 plus 22, which is 5. If I do negative 12 minus 17, minus a negative 17, I get 5. And again, 5, okay? Now, with all that being said, I'm also going to show you, you can do this with your calculator. You will plug those in, put your x's in L1, put your y's in L2, and then once you have those in your calculator, just check your regression models. Linear. Once you hit linear, because this is linear, your r squared would be 1. All right, r squared would be 1, and therefore it proves that this is linear. All right, linear. Okay. Hey, that concludes our third video for our final exam review. All right, make sure you tune in for the fourth video, Unit 10. All right.